everyone. I'm going to present a short case study on rational subgrouping. Now, the term subgrouping refers to the method of selecting subgroups or samples from the process in order to obtain data for our control charts. We want to decide the basis of subgrouping in a rational manner. And as an example, suppose a process is likely to deteriorate over time. Then taking samples based on time at regular intervals would be appropriate. If the process changes over time, the samples would then lead to the discovery of such changes. On the other hand, for a process in which the individual skill of the operators makes a difference in the quality of the output, then the subgrouping should be done based on the operator. That is, if the first group is taken from operator 1, the next subgroup should be taken from operator 2, and so on. Then if a change occurs to the process because of a difference in the performance of one operator compared to the others, the charts will show the change, and that change can be then traced back to the operator causing the difference. Such subgrouping, carried out to enable the discovery of a cause when it is indicated on the charts, is called rational subgrouping. Now we're going to look at an example. This is based on specialty cable harness assembly, in which the operation requires soldering of connectors at the end of cables, and this required a lot of eye focus. The final quality of the harness depended on the individual assembler. And the assembly line was experiencing a large amount of rejects at the final inspection. And a quality consultant was asked to help to try and find out what the problem was. So the first thing they did was they looked at the number of assemblers, 14 different ones who worked in one shift. Then the consultant considered each day's production as a sample, and they plotted a P chart. Now, we didn't cover the P chart in detail in our course. Of course, it's in our textbook, and we mentioned it in section 8.1. This P chart is a control chart used for measuring the percent defects in a sample. And what they show, it's just like our X bar and our control charts. This is with time, so days. You have an upper control limit and a lower control limit and a center line here. And on average, we have 11.5 defects, which is absolutely unacceptable in this assembly, scrapping over 10% of the product. But can you see any points that are out of control? All the points are in control. So it made sense to look at the control charts using a different type of subgrouping, because showing that the process is in control means simply that the assembly process is producing consistently the same proportion of defects day after day. And this proportion of defects, 11.5%, is not acceptable. So this is a typical situation where the basis of subgrouping should be changed to check if the subgroup by another basis would disclose the assignable cause. Now here it seems very obvious that it makes sense to look at the data in a subgroup by operator. So data were collected and the sample was changed to be 1 month production for each assembler. And again, the P chart was drawn with the assembler as the basis of the subgrouping. And this is what became apparent. Here you have the different number of assemblers. You have assembler 1, assembler 2, assembler 3, and you can see that assembler 4 and assembler 12 are very different from the rest. They have clearly more defects than the other. And on further investigation, it was found that both assemblers had very poor eyesight and needed glasses. The company provided free testing and free glasses. And to go even one step further, based on this assignable cause, the company offered free eye examinations and glasses for all the assemblers. And several obtained new prescriptions and new glasses. So the results. were astonishing. If you look at the P-chart, now this again is over time. Over the first 3 months, the initial level of 11.5% defects went down to 0.85% defects. This is a tremendous accomplishment just found with the use of the control chart. And then, of course, the basis of the subgrouping was changed back to the daily production after finding that the chart with the assembler subgroups was in control. And when the subgroups showed the progress in control, it meant that there's no more significant differences among assemblers. And the daily chart, like this, was a lot less work in data collection. So it's a short case on rational subgrouping, something that you can also apply then to your own SPC, statistical process control. Thank you.